Did you get that? Do I already have an account? This account is an end user account. He's trying to sign me into Azure. So I'm about to be signed into Azure. It's taking me to home environment. And you will definitely have access to this environment as well. The moment you have your AZ204 labs. Did you get that? This AZ900 is just to get you introduced, right? To Azure, right? Basics and capabilities of Azure. And this environment, all the things that we have here are the things you will definitely see by the time you people start working on Microsoft solutions tomorrow, which is actually the DevOps core training. So you would see that this is the Azure for students, and this is start with Azure free credits. Did you get what I'm talking about? So if this account were to be an account used by an organization to subscribe to Azure, this account is an account used to get what we call paid subscription. Paid subscription is different from this free trial, and it's also different from what we call the Microsoft Lens Sandbox, right? Which people will have access to. So the reason why we are looking at these accounts is to let you understand that these are all the signing methods to be able to explore, to be able to access and explore the Azure platform. So the number one, which is the Azure account, is the live account, right? Gotten the moment you subscribe to Azure using a paid subscription. So when an organization is getting Azure subscription, a credit card will be used. You get what I'm talking about? A debit card, yes. So that, of course, that card will be well funded. You get what I'm talking about? Because debit will be made at the end of every month. It depends on the payment method you've actually chosen, the organization has chosen with Microsoft. So there is what we call enterprise agreement. Enterprise agreement implies that an organization would make a payment, upfront payment, and that particular payment gets, deductions will be made from that particular payment, right, along the line. And it's usually within the period of a year. Did you get what I'm talking about? The good thing is that, you can actually move an outstanding, you can move a balance payment into the subsequent year, right? Because you might not be able to, it's not compulsory that you may exhaust the funds in your account, right? And with what we've discussed earlier on before we went for a break, you've understood the concept of Azure Cloud Computing in respect to elasticity, in respect to scalability. So because it's scalable, right, the cost and the charges, right, that will be made, for services being consumed by a large number of people won't be the same thing as the charges that will be made for services consumed by, small number of people. Did you get what I'm talking about? So that tells you that the charges will actually vary, right? It won't be the same. So you get to actually save cost. You got what I'm talking about? Because the moment you have about tens of millions of people accessing your services, all the servers will actually be initiated, will be activated, and each of these servers will have the highest level of hardware capacity it needs to function optimally. Right? That was what we discussed when we're talking about scalability. But we talked about vertical scalability and horizontal scalability. Each of these servers, being, let's say 10 servers, have to be started because this number of servers will actually be capable of meeting the demands of large number of people. So if the request, the demand has gotten to the peak, right? It simply implies that these 10 servers will actually be activated. But what if this number of users start dropping? Would these 10 servers, would they still be kept up and running? The answer is what? Would the total number of servers be kept up and running? The answer is no. So the moment the users reduces, the resources of this hardware and the number of servers will also reduce. So in such a way, you get about 4 servers running. The cost of keeping up 4 servers will be the same thing as keeping up 10 servers. That is the point I wanted you to note in respect to cost that will be deducted from your account, right? Being a live Azure account, which is the first option you have here. So I took you guys to the portal where I showed you people, all right, the different model. There is what we call the Azure free account, the one that comes with what we call free $200. And the good thing is that the moment you start using that particular account, you can exhaust that account before the stipulated deadline. Azure free account is an account that has a particular credit, tied to it, which can only be valid within the span of 30 days, within the period of 30 days. So you can actually exhaust that $200 within a day. You get what I'm talking about? There is what we call the Azure Free Student Account, where you'll be expected as a student, as an undergraduate, or as a student university to provide your student details. Some form of verification will be given so that you can have access to some services on Azure. However, there is a limitation because there is actually a particular amount of credit that will be given to you, which can be exhausted in no time. And the last one has to do with the Microsoft Learn Sandbox. So the Microsoft Learn Sandbox comes with pre-configured accounts from Microsoft directly. So that Microsoft Learn Sandbox allows you to explore anything that you need to explore in respect to the solutions you are trying to learn. You get what I'm talking about? In respect to the solutions you are trying to learn. So these accounts are just the accounts that you would need to access Microsoft Azure. But number one is the key thing, because the objective of this training is to equip you with the skills you will definitely need to be able to deploy solutions, especially functions, mobile applications on Microsoft Azure, right? Microsoft Azure. So let's discuss Azure architectural components. So here are the components of Azure. Here are the Azure architectural components. Azure regions, Azure region pair, sovereign regions. There's also what we call the availability zones. There's what we call the Azure data centers. There's what we call the Azure resources and resource groups. There is subscriptions, management groups, and there's what we call the resource group, subscription and management groups, which I'm going to also elaborate on, right? So let's get to look at the regions. If you could recall, you would remember that our main mention of the importance of provisioning servers on the cloud to host, provisioning a server on the cloud. I made mention of the components of the server. I made mention of compute, networking, and what we call the storage. So it is not possible for a server to work in isolation. When a server is actually spinned up, right, it's configured, and it has had services deployed on it, right? It has services deployed on it. That server will only be able to share its services when there is a network. And that was why we came across compute diagram, networking diagram, and storage diagram. And as far as server is concerned, the way a server works is that if any of those system units shuts down, it is only the volume, the storage volume, that keeps the operating systems that gets affected. I repeat, when a system unit among the array of system units in a server rack shuts down, it's only the operating system disk or volume that gets affected. The data that server provides, that server shares on the network, is not actually impacted. And the reason is because the data volume is not kept within the system unit operating system volume. The data volume is within the storage SAN. Is it clear? Now, it's just because we are basically discussing about fundamentals, and at the same time, we wanted to just have a grasp of what the capabilities of this environment are, so that we'll be able to at least understand and appreciate the technologies, right, that are behind the services we're going to be deploying. Yes, Babajide, please go ahead.
Apologies for taking it back a little bit. Can you please repeat the part where you said the data on the storage account does not affect that of the virtual machine. I'm not sure I put that
Thank you.
clearly.
Excellent question. Excellent. I'm talking about a physical server. Did you get what I'm saying?
Yes. Yes.
If you are talking about a physical server, in enterprise environment, there is a separate storage volume where the server keeps the services and applications is meant to share on the network. So that implies that the volumes must be mapped to that server. But the volumes mapped to these servers are not kept within the servers itself. The volumes, the storage volumes we're talking about are kept within a separate storage equipment. And that is why we have storage on that diagram. Please, can someone remind us the three components of cloud computing, that diagram we saw? Someone show me the mic and mention them.
Network,
compute, network,
storage,
and storage.
Excellent question. So I wanted you to understand why storage is separate. So the objective is to ensure redundancy, is to provide redundancy. So if a server crashes, it can be replaced, right, within the shortest period of time. Why? Because the data that server provides on the network is not kept within the operating system disk. You agree with me that every system has what we call disk, right? Storage volume, isn't it? All our individual computers, PCs, have what we call disk, right? Because our individual PCs, a PC used by by us individually, you can afford to, that machine can afford to have just a single disk. Do you get what I'm talking about? Because a PC is not meant to provide shared resources on the network, right? But a server, the objective of a server is to provide shared services and resources on the network. Because it's meant to provide shared services and resources on the network, it's imperative that it has a separate storage infrastructure where it needs to connect to spool, and when it needs to connect to and provide the data and the services it needs to share on the network. The reason why the structure was designed this way, are we there, is basically to mitigate the failure, right? To mitigate failure, right? Indefinite disruption. Because you can imagine if a server has a disk within it that stores its application, what happens if the server crashes? You get what I'm talking about? It simply implies that the disk hosting that operating system, being the disk that hosts the application, has actually been what? Lost. So that is unprofessional, right? So according to the diagram, we've all reiterated. We have a storage. Storage infrastructure is separate. Storage infrastructure is comprised of storage volumes that the servers are mapped to, where the server keeps the applications and services, right, they provide and share on the network. But before a server will have to access those volumes, it must boot up. That is your operating system, this concept. Is the concept clear to you now? Abajide?
Yes, it is. Thank you.
Now, yes, Abiola. Shiloh.
A follow-up question to your explanation, sir. Are you not saying that nothing can happen to a storage compatibility of a server? That is, nothing can happen to it? Because what I can understand is that the reason why the compatibility will separating them into three places so that data and services inside the storage can be kept safe in case the server gets any problem. At least the data and the services are safe in the storage. So are you saying that
Absolutely.
the storage?
Thank you. I lost you. I can't hear you anymore. Am I still audible?
Yes, you are audible, sir.
Yes.
Give thumbs up if I'm still audible.
Yes, you're audible. You're audible.
Okay. Okay. So thank you very much. And the answer to your question is what this diagram is all about, regions. Do you get what I'm saying? There are cases where you experience fire or disaster, right? Fire incidents, isn't it? Fire outbreak. When there is a fire outbreak, these storage equipments can also get fried. There's no doubt about it. But you can't afford to just have one physical location to keep your storage equipment. Is it clear? Right? So you're expected to have multiple locations across different geographical locations. Is that clear? Across different continents, and that is why this region that is what this region is all about. So regions are expected to provide what we call geo-redundancy. So if a particular physical location where you have a data center is being affected by fire or outbreak, you get what I'm talking about? The servers and those storages in that particular data center has replicas in other locations. So we can't say that these storage equipments cannot be affected. But you will see that it's rare because fire outbreak is not a common incident, right? But when it comes to server operating system, the server itself, anything can happen to a server. Did you get what I'm saying? If it's not properly maintained. So if, for instance, a server gets frozen, is it clear? Once the server gets frozen, you know that it has to be restarted. And if it restarts, it definitely means there's going to be a downtime, right? For a while, for some minutes or seconds. Is it clear? So that particular server, you won't experience a downtime because that server that is restarting is accessing the data it provides somewhere. So the storage equipment can actually be impacted, you understand, only in the event of fire outbreak. Exactly, and some other disasters like that, right? But, storage equipments are not prone, right, to all these impacts, right, like servers. Servers can experience transient hardware failures, right? Transient hardware failures. Did you get what I'm talking about? Because they run operating systems. So because they can experience these transient hardware failures, it is imperative that you don't keep the services and data they provide within the same volume that holds the operating system. Did you get what I'm talking about? That is why you have a separate storage volume, right? So, and not that you just have that particular storage equipment in a particular data center, because server racks, SAN equipment, SAN racks, network racks, router racks are within the data center. So that data center has the data center services, the services hosted on that data center are also hosted on other replicas, right? Data centers in different regions. And that is the concept called geo-redundancy. So regions are made up of one or more data centers in close proximity. They provide flexibility and scale to reduce customer latency. So I'm happy with this discussion we're having because, like the little one I've explained, you understand how it reduces customer latency. So if a particular server within a rack of maybe 18 servers maybe experiences hardware failure, am I making sense? All the active servers are there. You won't even know anything has happened. You get what I'm talking about? And the storage equipment, they have a dedicated network switches, right? Connecting them to the servers. And a particular data center has a dedicated, reliable, right, array of, what we call private WAN links. Private WAN links connecting those routers to all other data centers. Because in networking, a physical site gets connected to all other physical sites. This is what we call a live router. Within a network, within a physical location like a data center, you have different server racks hosting different set of services. And these different set of services are in different compartments, configured by what we call the switches. So the switches are configured to actually create those compartments of services you've had on these servers. But the servers you have within a data center has its replicas in other physical data centers, in other different data centers. So how are they able to communicate? They communicate via network. That network is on the diagram. So in networking, there is what we call switches, and the switches are the components within what we call a subnet. Right? Within a subnet. Within a subnet, you have switches, because a subnet is a network compartment. It's a network segment. So how we allow that particular network compartment to communicate to other location or other compartment would require a router. You will discover that there are some situations whereby you have organizations having maybe some servers, maybe on the 5th floor, maybe few servers, but on the 4th floor is where, or on the ground floor is where they have what we call the data center. In that scenario, you would definitely need a router to connect these two subnets together. But if that particular physical location is just a ground floor structure, and you have your servers there, that physical location is not just the only location that Microsoft has, because Microsoft has, you can see, as indicated on this slide, has about what? Over 60 regions representing over what? 140 countries. And each of these regions has more than one data centers, as indicated on the diagram you are seeing here. So the objective of these data centers across different regions is to ensure uninterrupted access to services hosted on the cloud. And regions, the last concept, please pay attention, the last point is there. Regions preserve data residency with a comprehensive compliance offering. I did say something in respect to compliance, right? Data residency on Friday. As we speak today, Microsoft doesn't have data centers in Nigeria. The moment Microsoft establishes data centers in Nigeria, you will discover that a lot of organizations, right, will be comfortable to start hosting their confidential data on Microsoft Azure Public Cloud, like databases. Did you get what I just said? Please respond.
Yes, we do.
Yes.
Because of the local law in Nigeria.
Thank you very much. So, but at the moment, Microsoft has no data center at the moment. So what businesses are basically trying to do is to see how they can actually ensure that how they can leverage on the speed, right, provided by Microsoft Azure Cloud Services in respect to accessibility, reliability of services hosted on Azure Cloud. So and that was why we came across hybrid cloud. Businesses today have a lot of their mobile applications, a lot of their web applications on the cloud. Did you get what I'm talking about? Because when that thing is on the cloud, their DMZ does not get overwhelmed. The DMZ will only be needed to safeguard and protect the proprietary applications kept within the on-premises infrastructure. So when people are when their customers of this organization are accessing their mobile applications hosted on the cloud, security is already taken care of by Microsoft. Is that noted, guys? So regions happen to be the different, geographical regions where you have different data centers, includes proximity, and it preserves what we call data residency. So there's what we call the availability zones. The availability zones is made up of at least one data center. Is it clear, guys? Availability zone is physically separated data centers within the same region. You get what I'm saying? So let's say Microsoft has Microsoft data center in Washington. So that means Microsoft will have multiple data centers in Seattle, right? If I'm not mistaken, yes. Seattle, Washington, right? These are two different, but they are in close proximity, right? They are in close proximity. But the objective is just to ensure that the servers across these data centers, right, provide these services the services hosted on these servers are highly available, right? The services hosted on these servers are highly available. So data center is equipped with independent power, cooling, and networking, right? Connected through what? Private fiber optics, as indicated on the slide. So before we talk about region, within a region, like a particular state, let me use Lagos for instance. Lagos has Surulere, right? We have Ikeja. You get what I'm saying? So you can imagine if there is a data center in Ikeja, data center in Surulere, there is close proximity. Rather than having a data center in Ikeja and having another data center in what? In Abeokuta in Ogun State. You get what I'm saying? So Abeokuta is a different region entirely. But as far as Lagos is concerned, Lagos could have his data center in Ikeja, another one at what? At Surulere, or another one on the island. So I'm just using that to actually explain to you what availability zone is all about. Now, how can I explain what availability zone is? Now, as far as Microsoft Azure is concerned, there is what we call region peers. These region peers are the kind of peers we have in some of these regions, as indicated here. You would see there is a region in US called what we call North Central. This North Central has a peer in South, called South Central. The objective is automatic replication for some services. And it's prioritized. It's a prioritized region recovery in the event of what? Outage. So the good thing about this thing we're discussing is that the functionality provided by this region is something that can also be provided when you are provisioning resources. So if you are provisioning resources, you can provide what we call availability zone. Is it clear? The reason why we are providing availability zone is to ensure that the services you are provisioning won't just be kept in one data center. You think what I'm saying? It's going to be kept across different data centers. Now, there are also what we call the Azure sovereign regions, because Microsoft is actually from United States. There are also regions in what? There are regions that are in United States that are basically strictly for Microsoft US governments, right? And that is what these sovereign regions are basically all about. Apart from US, there are also sovereign regions for China, right? There are sovereign regions for China, right? Sovereign regions for China. Now, I want to share these things with us. Please confirm if you are seeing if you can do this. I'm going to drop something. Please, am I still audible? Please respond.
Yes, sir, you are.
Yeah, can you please open up what I dropped on the chat and let's quickly take it up?
No. Sorry, it's not sure.
Wow.
Hi guys, have you opened up the link?
Yes, sir.
Yes, sir.
Yes, sir.
So the link will have something like this, right?
Yes, sir.
It's a globe.
Can you see my screen?
I've entered the lobby.
Don't log in. Just if you open the link, it will. Can you see this? Data center.
Yes, sir. Yes, sir. Can see it.
Navigate to take a tour, right? And click on Virtual Microsoft Data Center.
Wow.
So it's a simulation, right? That displays, that showcases, that walks you through the data center facets in Microsoft. Has yours appeared? Because once it has actually been rendered, please confirm if you are seeing what I'm saying.
Yes. Yes, I'm in the lobby now.
Fine, right? This is something you can do afterwards. Yes, Olajide, go ahead. Olajide, go ahead. I can see your hands raised.
My hand is not raised.
Okay. You can go through those things afterwards, right? Please, can we suspend that for now? And please, let's just pay attention to what I'm actually explaining to us from my slide. So another thing we need to also talk about has to do with Azure resources. So the moment you've had Azure subscription, you will definitely be able to explore these Azure resources. Azure resources are components like storage, virtual machines, networks that are available to build cloud solutions. You would see we have VMs there. VMs is under infrastructure as a service. Storage account is used in infrastructure as a service, right? Largely used in infrastructure as a service, and also utilizing platform as a service. And you will agree with me, there is what we call app services here, right? Can you say app services? And that is the focus of what we're going to be, exploring starting from tomorrow. There is SQL databases. These databases will have to be created so that they can actually store data generated by applications, right? When users interact with your applications. And would you want these applications to be accessible just via a public network like that, or via a dedicated network? So that's the essence of the network there. Now, when developing applications, it's not in all cases you want to write codes that will definitely perform tasks on real occasions, right? Or tasks that are not frequently carried out. So I'm going to use a practical example which I'm going to talk about tomorrow. Okay, maybe I'm going to leave that to tomorrow. So tomorrow I'm going to elaborate on functions. Is that noted, guys? So these things we're going to be looking at now. Please, can we mute our mics if you are not asking questions? Mute your mics, please. Here are the resources you can provision. So from tomorrow, you will definitely be able to provision, some of these resources. Azure App Services, storage accounts, virtual networks, and functions right from tomorrow. And there's what we call resource groups. A resource group is a group of containers you use to manage and aggregate resources in a single unit. You can't just create resources, and these resources will be left scattered, will be left unorganized. So whenever you are deploying an application, that application will definitely need to connect to a database. That application will definitely need storages. But because it's an application meant for a particular purpose, you are meant to create a resource group for the purpose that application is being created for. So the essence of resource group is to consolidate objects, to ensure that objects are well grouped so that they can easily be managed and administered. Resource group, right, is just similar to organizational unit. For those of us on this call that are experienced with administrators. So on Azure Cloud, we don't have organizational units, but within on-premises infrastructure, there's also organizational units. The objective of a resource group, right, is to organize resources so that can easily be administered and managed, right? Resources can exist in only one resource group. So you can't have resources existing across multiple resource groups. So if you have a resource created for account department, for instance, or a mobile app that will be created for a set of users, and that mobile app is a loan application, for instance, because the purpose is loan application, you can name the resource group loan application. So the naming resource loan application means the app service will be with the storages within the resource group and the other things that will be created for your applications to work. So it is impossible for that web app services within that loan application resource group to exist in another resource group, right? But resources can exist in different regions. Resources can exist in what? Different regions. Why? Because we're talking about the data, the servers. These servers are machines provisioned, right, to share the same set of services, right, to provide redundancy and provide high availability. Resources can be moved to different resource groups, yes. So if you've had a resource group, you can create a new resource group and move the resources within a particular resource group to another resource group. That is practical. And when it comes to the applications you've deployed, like the one that has to do with what we're going to start exploring tomorrow, right? Applications can utilize multiple resource groups, because when you are developing an application, you are going to adopt microservices method. You get what I'm talking about? Microservices method. So your applications, when they are actually being accessed by users, either on mobile devices on their systems, would actually be visible to users seamlessly, and those applications will be made to reflect new themes from time to time. So those new things might need to span across multiple resource groups. What it simply implies is that application people are accessing is made up of different applications, modular applications kept in separate resource groups. And that is where the last concept is. Applications can utilize multiple resource groups. I did talk about Azure subscriptions here on. This is actually the payment. Azure subscription is the billing boundary. It's also the access control boundary. And the Azure subscription with the authenticated and authorized access to Azure accounts. Right? So it's got to do with money. You got to tell about money. So the credits assigned to your account will determine how long you'll be able to explore the resources we've discussed. Not quite long. Resources like VMs, functions, app services, databases, storages, virtual networks. So the moment your credits, finishes, right? You won't be able to access those resources again. Do you know what I'm talking about? Until your subscription is renewed. In an enterprise organization, right? A typical organization, for instance, a financial institution or insurance company, right? You agree with me, they have what we call presence in different geographical locations, and that is what makes them what we call an enterprise organization. So if such an organization want to deploy mobile applications for its customers to actually access, and we want to keep improving the functionalities, the features available on these mobile applications, it simply implies that there is going to be a team in that organization called the DevOps team. So what the DevOps team will definitely do is to ensure that they get they roll out of their applications and create a channel for feedback to be gotten so that they will make informed decisions to improve such application by adding new features, right? Retracting ineffective features from the applications from time to time based on the feedback they've gotten. And that explains the reason why you have different subscription. So such an organization like Finance Organization and the likes would want to have different subscription. Is it clear? Under their account. So under the account, there is a particular subscription for development. There is a separate subscription for testing. There is a separate subscription for production. Why? Because development is actually a group of team members. Because in development, if you look at DevOps involves collaborations between the development team and the operations team. Because the operations team will give continuous feedback to the development team. And the software's modifications that will be made to the software being deployed, right, will be informed by the feedback given by the IT operations teams. Because DevOps is from development and operations. So you will see there is a dev subscription, which is a subscription that avails all the developers the subscription to access every tools they need, such as Visual Studio Code, Grafana, or whatever tools that these developers are conversant with. Because they know what it takes to tweak the code to ensure that new features reflect on that particular application. So you wouldn't want a single subscription to be responsible for both development in testing and production to avoid conflict. So dev team is basically for developers so that they can start developing the applications. Without dev subscription is a particular subscription that will give the dev team access to whatever they need to develop their code. Because the moment we start tomorrow, you will discover that you're going to be accessing what we call Visual Studio Code in your lab environment from time to time. And you'll be accessing what we call Azure Cloud Shell. The Azure Cloud Shell allows you to use scripts exactly to carry out tasks. Is it clear, guys? So while developing your solution from time to time, you'll be using what we call batch scripts or PowerShell scripts. And you would have to launch your Visual Studio Code, right? So that you can use your Visual Studio Code to commit the code, the changes is made to your code to the target repository. When I say repository, I'm referring to a central repository containing the code, right, modified by different group of programmers or developers. That is repo. So that repository is meant to be compartmentalized, right? Divided into different containers. Why? Because you will definitely have different features to be updated from time to time. So dev subscription is just that aspect that avails the developers access to the Visual Studio Code or whatever tool they are actually comfortable with to develop and continue to modify the applications. Whenever an application is being developed, right, it needs to be tested, it needs to be validated, it needs to be vetted to ensure that it aligns with the requirement specification, which has to do with the feedback, what is actually wanted to see. And once it has actually been vetted, validated, what is being vetted, because this group of people are the people working under using the test subscription. I would there. People under the test subscription, once they are done vetting what is being done, what has actually been vetted is now going to the transition into production. So there is a team in production. Pilot users. Am I making sense? A lot of people that will need to test what needs to be. Not pilot users. Pilot users are in test environment. Production subscription is actually the subscription, right? That actually keeps or avails users, right, the opportunity to access this application. So when an application is being modified, the new features added to the application will be seen and available to users. That is under what we call production subscription. So from time to time, by the time we delve into our core aspect tomorrow, I'm going to elaborate on this, right? Because there are a lot of technical things I'm going to actually simplify right tomorrow. So there's what we call management groups, apart from subscription. If you look at the subscription, you would see that the subscription has different granular, right? Isn't it billing account? Because subscription has to do with money. Do you know what I'm talking about? Because in developer subscription, you have a lot of developers using the Visual Studio Code to do their work. So that simply means that they don't need to be looking for licenses for Visual Studio Code anymore. The business provides the Visual Studio Code ID that these developers will need to develop their applications. Is it clear? The testing subscription avails the key weighting, quality assurance team to vet what has actually been tested. They also adopt some testing validation tools because this testing also can be automated. So these testing tools are actually the tools they will use to test, validate the code to verify if it conforms with the requirements that has actually been specified. Now, let's talk about management groups. Management groups are basically used to compartmentalize your subscriptions, right? Management groups are basically used to compartmentalize your subscription. So this subscription you are seeing now, are we together now, right? You will definitely use what we call management group to actually enforce it. The subscription in this case has to do with money. What is the cost implication of keeping these services available to all the programmers, key weighting, and users that will access the applications, right? Now, looking at it from technical perspective has to do with management groups, right? So the essence of management group is basically to group your resources, right, into different subscriptions. So when I say group your resources, I'm talking about grouping your virtual machines, grouping your SQL servers. And remember, before we got to this point, we've already talked about resource groups. Now, if you look at resource groups are actually used to group whatever resources you would like to host on Azure. So these resources are grouped because you would like to understand what the purposes of these resources are, right, when they are actually provisioned on Azure. So the essence of management group is to basically delineate to ensure this dev testing of a thing we are talking about. Is it clear? So management group allows you to compartmentalize the subscription. So you have a management group of development subscription. Are we there? Within that development subscription, that means you need to create a resource group. Is it clear? So that resource group or the resource group is there, and the resource group created to group all the resources that developers will need in their subscription. And that's what management group is meant to do for you. And that was why I said resources. Can you see it, guys? The Visual Studio Code, everything that these developers will need to have access to. Right, we call them. They are actually defined in management groups. And the beauty about management group is just like resource group, but the management group is at the subscription level, right? Because either with management group or resource group, you can control access to these resources. Yes, Abdul Jabbar, I got it. Go ahead. Abdul Jabbar, I saw your hands raised. Okay. I was expecting. Hi guys, please give thumbs up if I'm still audible. Some of us will give thumbs up, please.
You are audible, sir.
Thank you very much. So management groups will have to be created because you are trying to separate the subscription because you don't want a situation whereby the team of administrators security guys, mapped to dev team, won't have access to resources in test subscription. Yes, Abdul Kabir Subar. Hi, Abdul Kabir.
Yes, I'm with you. You've answered my question. Thank you.
Okay, thank you very much. So the essence of you creating management groups, resource groups, looking at it from technical perspectives, you and I are professionals. We're professional in the sense that we decide what resources group users should have access to.
Daddy smokes.
You decide what resources that users should have access to. Is it clear? You decide that actually, right? So how would you decide that? You use what we call resource group. You decide what we call the management groups. Management group is at the subscription level. It's just like an enterprise admin, right? In Active Directory. It's just like global admin on Microsoft Azure. Why the resource groups is to actually ensure that you have different resources, right? Managed by different levels of administrators. And these different administrators will not trespass, right? You understand, into other administrators' environment. So let's talk about computer networking. So in computer networking, we're going to be looking at compute types, and we're also going to be discussing some of these things we're going to be looking at. So let's just get to the computer networking. So let's start with Azure Compute Services. Easy. All these things you are basically looking at, each of these things will require hardware resources. What do I mean by hardware resources? Each of these compute resource services will require processor cores, CPU cores. Who can tell us what is a processor itself and what the processor cores are meant for?
It's the amount of the speed of processing a task by a computer.
Yeah, what, Farouk?
Yeah, I say it's the measurement of speed of processing a task by a computer. That's what it does, the processor.
Thank you very much. You just received an applause. Thank you, Farouk. So that is just it. It's clear. That is just it. Thank you very much, Farouk. So any of these compute services would utilize a processor speed, processor cores. And the higher the cores, I want to get it now, the higher the speed. When a system has one processor core, it won't be as fast as a system that has two processor cores, like Farouk said. So processors is what determines the speed of a system. And the processor doesn't work alone, it works with memory. And the moment a processor works with memory, the demand will be placed on them when users are requesting access to the resources on the machine utilizing them. A server utilizes disk, right? A server utilizes processor. A server utilizes memory, provided that a demand has been placed on it. You understand? Users are requesting access to the services it provides, it shares across the network. How would servers share services with users? It's obviously through the network. You get what I'm talking about? But before we talk about network, let's talk about the compute services. Compute services is a virtual machine. When you're creating a virtual machine, you need to specify the disk capacity, the memory capacity, and the processor cost for that particular VM. When you're provisioning app services to host your application, you will want your application, the speed, right, to be very, very what? Fast. Did you get what I'm talking about? So you want it to be very, very efficient. and you want the speed to be optimized. So you want to look for different plans, because each of the plans we're going to start exploring tomorrow comes with cost implication. So a plan that has one processor core has its cost. Did you get what I'm saying? Which is not up to a plan that has two processor cores. The same thing goes for a plan with one processor core having maybe about 2 gig RAM. So if you have one processor core having 2 gig RAM, you can imagine if you host an application on it, that means that application is not going to be an enterprise application. So, and I will explain why. Because it's just a particular instance of a machine, right, on Azure Cloud, and that machine has 2 gig RAM and 1 processor cores, right? 2 gig RAM and 1 processor cores. Is it clear? It has 2 gig RAMs and 1 processor cores. So the application of hosted on that app services, having it that has this capacity, won't be as fast as an application that would be hosted on app services configured with 4 processor cores, 32 gig RAM. Can you see the difference, guys? So that is what brings about these compute services. The same thing applies to container instances. The same thing applies to Azure Kubernetes services. The same thing applies to Azure Virtual Desktop. Because all these things are compute services because they utilize hardware resources like these processors, memory, and they obviously need a network so that they can actually be utilized. So Azure Virtual Machine are software emulations of physical computers. So your physical laptop can be virtualized, right? So virtualization actually came up right from Windows Server 2008 R2, to be precise. Is it clear? When we started having Windows 8, those things came with virtualization features. Is it clear? Windows 7 to be precise, yeah. Windows 7, yeah, came with virtualization features. So it simply means that you can have multiple instances of operating system on a single machine. So on Microsoft Azure, because it's a cloud, computing, which helps you to deliver services over the internet. These services will be consumed virtually. Is it clear, guys? Will be consumed virtually. Because you can't actually travel down to Washington to be able to, connect to the physical servers. So it is the virtual machines that, have been spinned up on the Microsoft Azure Cloud that will host the services that will actually be shared across the network, typically the internet, with users to access on their devices and computers. Now, a virtual machine represents a single point of failure. We can explain why. A single virtual machine represents a single point of failure, or a single computer represents a single point of failure. Who can tell us why?
Because of the single availability zone. If something happens to the data center where your data is stored, your infrastructure becomes lost.
Because there's no backup service.
I think that's too far. For virtual machines, if anything happens to that machine or it goes down or crashes, your application goes down. Can you hear me?
Hello.
Your line is breaking. Okay, thanks a lot for your contributions, your responses. So like you've all rightly said, the reason why a single VM or a single computer represents a single point of failure is because it has no backup instance. Is it noted, everybody?
Yeah.
Please, A virtual machine is different from a data center. A data center is made up of large number of server racks. It's made up of multiple server racks, and each of these server racks is comprised of multiple instances of system units of computers, physical computers. So a server rack itself is not a server rack itself is meant to have a replica. Did you get what I'm saying? Okay, maybe that was why you made mention of that data center. So I want to appreciate your responses. Those of us that responded, all our responses, you were all spot on. Thanks a lot. Now, what brings about our availability in respect to virtual machines is this concept called VM scale set. So a VM scale set provide a load balanced opportunity to automatically scale resources. And this is the concept behind horizontal scalability. So when you say scaling horizontal scalability, you're talking about increasing the number of instances based on demand. So if you have maybe 20 users, right, currently accessing your mobile application on their mobile devices, you agree with me that 2 machines will be enough, isn't it? Or 1 machine is enough? Is it not enough? Hi guys, but we would say 2 because we said 1 represents single point of failure. Please respond.
Yes, it is.
And when you respond, please mute your mic back.
2 is enough, sir.
Thank you. So now, but you may have actually deployed maybe 20. So if you've had 20 of these VMs, these 20, the entire 20 VMs will only be activated if the number of users has gotten to its peak. Is it clear? If the traffic has gotten to its peak. Right? But the moment the number reduces, those VMs from 20 will start reducing maybe to 15, maybe to 14, maybe to 12, maybe to 10, maybe to 8.
I'll change that for you.
Right? In such a way, you as a subscriber subscribing to Azure, hosting your service on Azure, save costs. Is it clear, everybody? So it is not actually meant to be a fixed thing, and to be kept at 20. Because 20 VMs, it's like you are wasting resources if these VMs will only be accessed by few number of users. So they will actually be scaled based on demand. Hi, Afolabi, please go ahead.
Voucher to write.
Yeah, so based on what you just said right now, is there a standard number? Like, okay, if I want to use, like, let's say, if 1 to 1 million people are already on this,
obviously,
that means it has gotten to its peak. Then the next virtual machine is automatically the other ones move to the other machine. I'm just talking about numbers because you're looking at numbers right now. Is there a specific number? Okay.
Yes. So a VM scale set has what we call a rule. There is a rule that controls it. Is it clear? The rule would definitely adjust the resources based on the demand. Is that noted?
Yes, it is.
So, but now, maybe if I got you correctly, you were saying that, how do we know if it's 20? Can it be 50? Is that what your question is? Can it be 100?
No. You've already answered it. That there is a rule that guides, that knows the number of resources that are being used. Then when it gets to that's getting to its capacity, it moves to another
it scales out. Yeah, it scales out.
Yes.
It scales out. Now, when it comes to VM availability, there's what we call VM virtual machine availability set. Now, remember, we did talk about racks. Can you see these racks? Hello, guys. Can you see this rack of servers?
Yes, we can.
Yes, we can.
Yes. There is 4 domain 0 rack, 1 rack. Thank you very much. And there is 2. Is it clear? Now, the reason why you have this is because from time to time, servers hosting operating system are meant to might have to restart due to Windows updates. Do you agree?
Yes.
Yes.
Hello, everybody.
Yes.
Yes, we are.
So UD means update domain. Is it clear?
Yeah.
Yes.
Update domain is a domain that will definitely keep group of servers currently restarting. And there will always be active servers. Is it clear? Online. Because all servers are not meant to complete the installation of the update at the same time. Do you agree? Is that noted?
Yes.
Yes.
So that is the concept of what? Fault domain and update domain. This is to provide fault-tolerant access, right, to those virtual machines. So because we know every machine is hosting with this operating system, we obviously need to install updates. Is it clear, everybody? Please mute your mic. Mute your mic. Farouk, can you mute your mic? Whoever is on has his mic on should mute his mic. Okay.
But I attended one to learn you are not what I thought. You were listening to me.
There is another concept called Azure Virtual Desktop. Azure Virtual Desktop is a desktop and have virtualization that runs in the cloud. Right? So Azure Virtual Desktop is a desktop and have virtualization that runs in the cloud. Azure Virtual Desktop is just like you trying to create a virtual desktop so that users don't use their own personal system. Is it clear? To access the application you want them to access. So an organization might want to actually standardize the applications they want users to access, right? So systems they would use won't have to have these applications installed. Now, to achieve that objective, we deploy what we call Azure Virtual Desktop. Azure Virtual Desktop. Now, another critical thing is got to do, critical compute services is got to do with Azure Container Services. So Azure Containers provide a lightweight virtualized environment that does not require operating system management and can respond to changes on demand. When your applications are containerized, the application can be deployed to any target. So, for instance, if you deploy an application on Windows platform using .NET, that application can seamlessly run on Linux operating system because a container comes with all the dependency features and libraries, runtime that particular application needs to function, irrespective of the operating system running on the target environment where it needs to be deployed. So we have different technologies on Azure, right, for these container services. There is what we call the Azure Container Instances. The Azure Container Instances runs on a container or pod of containers. So the objective is just to ensure that your containers become highly available. Is it clear, everybody? Your containers become highly available. Yes. Just like when we discuss VM, virtual machine, and virtual machine skill set. So you're expected to have multiple instances of containers running. Is it clear? Multiple instances of containers running.
Hello.
So there's also what we call the Azure Kubernetes services. Right? So the Azure Kubernetes services is an orchestration service for containers with distributed architecture and large volume of containers. So Azure Kubernetes services, has different pods, right? Is that clear? Large number of pods. Is that clear for your container? Right? Large number of pods for your containers. And the good thing is, another objective is these Azure container applications, as you can see on the diagram. The Azure Container Applications also avails you with different container instances that can load balance and scale, right? That can load balance and scale. So these are just container services that would be expected to be provisioned to keep your containerized applications up and running. Container instances are things you deploy on Azure. When you need to deploy containerized applications accessed by small or medium-sized organizations, accessed by users in small or medium-sized organizations. Is it clear? Right? But when it comes on a large scale, an enterprise scale applications will either use Azure container apps or Azure Kubernetes services. Did you get the explanation I just gave in respect to the differences?
Yes, sir.
Thank you. Now here comes Azure Functions. Azure Functions is a platform as a service offering that supports serverless computing operation. Event-based code. Event-based. Please, I want us to know that event-based. So Azure Function gets fired only when the event that needs to fire it occurs. I repeat, an Azure Function gets fired only when an event that needs to fire it occurs. Is it noted, everybody? So for those of us that are new to this particular technology, be rest assured that I'm going to discuss extensively on Azure Functions by the time we start the process of developing solutions tomorrow. Is it clear? There is what we call the Azure Compute. So here are the Azure Compute options and scenarios where these options can actually be used. Virtual machines is used in lift and shift migration to the cloud, which I mentioned earlier on. And that is under infrastructure as a service. Virtual desktop is when you want multiple users to access the same desktop at the same time. So if you need to allow 10 users or 5 users to access the same desktop, or 15, 20, you can imagine the cost of procuring 20 machines for these 20 people. So if the business feels for compliance reasons and for cost implications, factors, it's more effective, right, to deploy a virtual desktop so that they will use this thing. The business will have to deploy what we call a virtual desktop. See, the virtual desktop implies that the business doesn't need to give the user employees laptops to access the applications that the business wants these employees to access. So these employees can use their personal systems or their mobile phones or mobile devices to access those virtual desktops. Why container? A container is basically what is used. Containers are used for our applications, right? This is where we build our applications, deploy our applications, and we test our applications, right? Now, app services is a fully managed. App services is a fully managed platform to build, deploy, and scale web applications and APIs quickly. And what scale quickly? So, as far as app services are concerned, you would see that there is what we call APIs, right? There's what we call APIs, right? I believe most of us would have had prior experience, knowledge of APIs, right?
Yes, sir.
Thank you very much. So this is where you get to what? Build, deploy your APIs, your applications. And there's what we call runtime. Runtime involves .NET Core, Node.js, Java, Python, and PHP. And there is a platform as a service thing. So the truth is, with these app services, and containerization. If an application is developed with .NET, right? If an application is developed with .NET, it doesn't necessarily mean the target where the application will be deployed to must be Windows. That target can be what? Linux, right? The target can be what? Linux as well. The target can be Linux. So app services is just a core thing, a core aspect of the DevOps thing we are discussing, which will start tomorrow, which is where we actually what? Build, deploy, and scale our web applications and our APIs. Now, let's talk about the Azure Network Services. A virtual network enables Azure resources to communicate with each other, communicate with the internet, communicate with on-premises networks. So now, while taking note of the hybrid cloud computing we spoke about earlier on, you would also realize that a virtual network is what makes it possible for the on-premises infrastructure to communicate with the services it has extended to the Azure public cloud. Hybrid cloud is comprised of what? On-premises infrastructure, isn't it? And what? Public cloud, which is Azure. So if the business organization has had the mailboxes of some employees, right? Let me use mailboxes of employees. If the businesses have had, if the business organization has had the virtual machines hosting some applications, web applications on-prem, on Microsoft public, Azure public cloud, right? A virtual network will obviously be needed to ensure seamless communication between the employees' devices within the on-premises infrastructure and those migrated virtual machines on Microsoft Azure Cloud. Did you get what I'm talking about? So lift and shift migration method we spoke about is a kind of method that helps us to move virtual machines hosting applications on on-premises infrastructure to Microsoft Azure Cloud. Did you get what I'm talking about? Azure Cloud. Is it clear? So you can imagine when a business wants to move some data to the cloud. Did you get what I'm talking about? And those things are on the VM, right? And there are no compliance restrictions, right? Of course. How will they be able to do that? Because they are on the VMs on on-premises infrastructure, they will only be able to move them to the cloud seamlessly. And once they are moved to the cloud, how will they be accessible to employees within on-premises infrastructure? It is via what we call the Azure Virtual Network. So Azure Virtual Network is a public endpoint accessible from anywhere on the internet. It does have what we call the private endpoint as well. So public endpoint is what is the default. Public endpoint is the default setup for our app services. Is it clear? So the moment you roll out application on Azure, is it clear? You would want such an application, right, to be accessible outrightly to users, right, without any form of disruption. However, there are some cases where you want the new versions of this application to be available to few users. And we discussed that when we talk about tests, right? Development and production, right? Remember we talk about development, test, and production. So in the testing phase, it simply means the application that is being validated will not be available to the end users. It will be available to the group of QAs that will do due diligence to ensure that the new things that have been introduced to the application are the new things the end users actually want to see on that application. And that is what that private endpoint and the concept called virtual subnet segment. Virtual subnet, which segments your network to suit your needs, is all about. Is it clear? And there's what we call the network peering. Are we there? The network peering ensures that private networks communicate, right? Private networks communicate. Now, having explained the possibility of integrating on-premises infrastructure network with public cloud to establish what we call the hybrid cloud, we're now getting to understand the security mechanisms that actually encrypt and protect the communications established between on-premises infrastructure and the virtual machines or resources hosted on Microsoft Azure Cloud. One of these concepts in Azure networking services is called VPN gateway. VPN gateway is used to send encrypted traffic between an Azure virtual network and an on-premises location over the public internet. In other words, it conveys that information using public IP addresses. Now, you will discover on the slide, you will see there is 131.1.1, that's a public IP address from the cloud network, virtual network. And there is 33.2.1.5, which is a public IP address from the on-premises local network. So VPN gateway, right, would involve the traffic between on-premises infrastructure and the public Azure cloud traversing the public network. But this communication will have to be encrypted. We pass through what we call an encrypted tunnel. Is it clear? An encrypted tunnel. So this is similar to the networking guys, the CCNA guys, the CCNP guys that we call. It's similar to the site-to-site VPN. Is it clear, guys?
It's clear.
Yes, it is. Someone was asking a question about is that both 104. Some of the things in 104 are the core things we are basically discussing about. Are we talking about? So this VPN gateway is something that we want to implement if the business organization feels, look, the internal machines that will communicate, with the machines on the cloud in this hybrid environment can actually be made to communicate over the public network. But if the business deem it necessary to make the communication more confidential, then you implement the next thing called what? Express route. What is it called, guys?
Express route.
Express route.
Remember, VPN gateway ensures that the traffic traverses the public network, isn't it? Express route ensures that the traffic traverses a private connection using a private IP address. It's easy to everybody. It's just like the way a router works. The router has two WAN links, the public WAN link and the private WAN link. The private WAN link connects all the physical locations of an enterprise organization together. So if a financial institution, if an organization is a financial institution, for instance, and the organization being a financial institution has multiple locations across different regions, all these locations will communicate, right, using what we call through the private WAN link, because the communication won't have to pass through the internet. It doesn't need to pass through the internet. So there are times you need to pass through the internet. If it passes through the internet, that means you need to adopt what we call the site-to-site VPN. Is it clear? So it depends on the scenario that plays out, that is playing out. So if the scenario has to do with fine, there is the information can traverse the public network. There's no issue with that. You use what we call the VPN gateway. But there are instances where the business is trying to be more discreet about how this information is being conveyed. They don't want that information to pass through the internet. They want the information to pass through what we call Microsoft Network Backbone. Is it clear? Microsoft Network Backbone. Microsoft Network Backbone is a dedicated private network, and that information won't actually be conveyed using what we call private IP addresses. It uses, won't be conveyed using express route. Don't convey that information using what public IP addresses. It conveys the information using what we call private IP addresses. So in other words, express route is actually to a large extent, right, is more secure than what? VPN gateway. For information like database, is understood that is meant to be accessed. So when you want databases to be accessed by a web application on Azure Cloud, a database kept on a premises infrastructure to be accessed by a web application on Azure Cloud. In that scenario, you wouldn't want to use a VPN gateway, right? You usually call what? Express route. Is it noted, everybody? Because express route is more protected and secured. It's very more protected.
Question, sir.
Please go ahead. Yeah.
So we're looking at currently express route for private network communication and VPN gateway for public network. So my question now is, where does encryption comes in? Do we need to encrypt anything, whether we're doing it privately or publicly?
Thank you for that important question. These technologies comes with built-in encryption. Is it clear? You would see for VPN gateway, this is IPsec, right? Hello?
Yes, we're following, sir.
VPN gateway is IPsec. You know what I'm talking about. That is encryption. So it's a built-in functionality the moment it's implemented. The moment you configure a VPN gateway, those security encryption mechanisms get activated automatically. However, this is a communication that traverses the internet for VPN gateway. Is it clear? So if the business deems it necessary to keep such an information highly confidential, they want to implement what we call express route to ensure that that particular communication does not traverse the internet. It traverses a dedicated private network. And that was why I made mention of Microsoft Backbone Network. Is it clear? Microsoft Backbone Network does have its own encryption security, sophisticated encryption security settings, right? And configurations. Is it understood now?
Yes, thank you, sir.
Now, there won't be any way. Let's talk about DNS. So DNS is basically what makes the company's business name, right? DNS is got to do with security and authentication, right? Without DNS, it would be impossible for standard names made up of English words or different languages to be understood to the computer or servers. Without DNS, it means servers will only be able to talk to clients. Please go ahead.
Alright, sorry to interrupt that, but before we go to this Azure DNS, we're talking about the express route and how to provide the connection to the Azure platform using local IPs. I want to know, since they are going to be using local IPs, it means that it will be like a local connection that's not going to be passing through the internet, which is what you clearly said, unlike the IPsec side-to-side VPN that will be using a private connection. So let's say we want to do that connection to Azure using the express route. How do we interconnect to the Azure network backbone? Or do we have local providers or maybe data centers in the country that does that? How do we interconnect to the Azure backbone?
Thank you very much. Thank you very much for that interesting question. So express route, right, is configured when you are trying to configure Microsoft Azure Backbone Network with the network service provider the organization uses. Is it clear?
Okay, so connect it with the service provider of the on-prem.
Yes. Yes. But mind you, this connection passes through the private WAN link. Is it clear now?
Okay.
It's a Cisco port, you know that by private WAN link.
Yeah.
Thank you very much. So this private one link, right? This private one link, the objective is just to ensure that it becomes more secure. That is just it. So there are certain configurations that we have to be done, right? There are certain configurations that have to be done. Is that noted? Have I answered your question?
Yeah, that was noted. Thank you.
So now let's go to DNS. Now in DNS, without DNS, it will be impossible for your domain business name to be recognized, right, by the servers. Is it clear? Your business name cannot be used on any computer. So the DNS allows your company name to be recognized by the computer. And when it comes to DNS, we do have what we call the public DNS and the private DNS. So it is imperative that you do what we call the public DNS registration and verification. And when you're registering your public DNS, there's what we call the name servers, all these TXT files you need to configure. The objective is just to ensure that you map the public IP address that your on-premises infrastructure uses, right, to that public DNS name. So that whoever searches that public name online will find the server that contains the services that the users should have access to. Now let's move on to storage, right? Now, as far as storage is concerned, remember I already explained to you guys that storage is a dedicated environment, right? Your infrastructure uses. Is that clear? Right? Now on Microsoft Azure, before you can have access to storage, you must have created what we call a storage account. So the process of provisioning things on Azure is very, very simple and seamless. Do you get what I'm talking about? And that is what distinguishes Azure from other service providers. Is simplicity. Exactly. So a storage account is a resource that needs to be created on Microsoft Azure before you can start provisioning storage, storages. And as you can see on my slide, when creating a storage account, it must have a globally unique name, and that is what provides over the internet access worldwide to your storages, and it determines storage services and redundancy options. Right, storage services and redundancy options. As far as this storage is concerned on Microsoft Azure, it is primarily utilized by all the data centers across the regions we discussed earlier on. So all the data centers across the region, would utilize this storage. So when it comes to storage redundancy, there is what we call local redundant storage, zone redundant storage, geo-redundant storage, and geo-zone redundant storage. Local redundant storage is a single data center in a primary region. Right? It's a single data center in a primary region. So local redundancy is, so what that implies is that if you while creating a storage account, if you select local redundant storage, it simply implies that that storage is within a single data center. Right? And the uptime is level 9. Can you see that, everybody? So you see that the uptime is still high. Is it not high? It's still high. Why? Because anything kept within Azure data center is unlikely to experience failure or downtime indefinitely. Did you get what I'm talking about, everybody? So if you look at that, you see 99.99, can you see level 9s? Uptime, durability is what is being ensured, guaranteed by locally redundant storage. But when creating a storage account, when you're trying to provision a storage, you want those storage to have replicas in different data centers. in different data centers, in different data centers. So you have the selector we call zone redundant storage. The objective of this redundant storage is just to ensure that, look, the storage you are creating is not kept within one physical data center. Is a storage shared across different data centers within a region and across regions. Because across regions is when you have what we call geo-redundant storage. Because geo means you have a primary region and you have a secondary region. So looking at what we've discussed earlier, let's say you have Lagos, right, as a particular region, and within Lagos you have 3 data centers. If you are selecting, within that you have 3 data centers in Lagos, and you also have Abuja, right, as another region in Nigeria, right, and in Abuja there are also going to be 5 data centers. Geo redundancy, right? What I'm explaining is basically geo zone redundant. Geo redundant storage applies to when a scenario where you have a data center in Ikeja, and a data center maybe at Surulere or on the island. Is it clear? So because you have different data centers, is that clear? Across different regions, right? That represents what we call geo-redundant storage. And there are scenarios where you wouldn't have multiple data centers, not just in Lagos. You have it in Abuja, you have it in Ibadan, you have it in Kaduna. Is it clear? You also have it maybe in Pretoria in South Africa. You have it in Accra in Ghana. Is it clear? You have it maybe in Zanzibar in Tanzania. And you have it maybe in UK, right? In that scenario, that concept is called geo zone redundant storage. Geo zone redundant storage. So the objective for this storage redundancy is just to tell you the availability, how highly available, right, this storage will become. Azure storage services, there are 5 Azure storage. Please go ahead. Yes.
So when I am provisioning for a storage or apply for a storage, I must use all these 4 options, or am I limited to use only local redundant storage?
You can use any of them, only one of them. Is it clear? Depending on the scenario that is playing out, that plays out.
Yeah, it's clear, sir.
Thank you. So for an organization that has multiple locations, not across Africa, are we there? Across the globe. What are we going to use in this context, guys? Thank you very much. But an organization that resides only in Nigeria, what are we going to use? What if it resides only in Nigeria?
That would be
redundant.
Zone redundant storage.
Thank you very much. I'm so happy and impressed with the level of our participation. So now let's talk about the types of storage services. There is Azure Blob Storage, Azure Disk, Azure Queue, Azure File, and Azure Storage, Azure Tables. So these are the different storages that can actually be worked. Not Zoom, is Zone. Zone redundant storage, right? So here are the different storage services that you can actually deploy on Azure. For the purpose of your own skill set, right? What we deploy in most times will be what? Azure Blob. Is that noted, guys? Because Azure Blob is optimized for storing massive amount of unstructured data as text or binary data. Do you agree with me that your container images are made up of codes that cannot be read ordinarily? It's just like if you are trying to open an exe file. If you open an exe file, what appears? All of us are familiar with .exe files.
And is it table file for application?
If you open it with Notepad, what do you see or what? What do you see? Unfamiliar codes, right?
It will be gibberish, yes.
It will show codes. Yes.
Thank you very much. So that is the way container images. You think what I'm talking about. So as a matter of fact, if you are going to explore this blob on Azure, it's called a container. Azure Blob, as one of these Azure storage services, is also known as container. Azure the Azure is also known as well. Now the virtual machine, you are deploying an application or other services on Azure. That particular thing definitely uses storage to store its data. The Azure disk itself is one of the Azure storage services. Another Azure storage service is what we call Azure Queue. The Azure Queue is to ensure seamless storage and retrieval of large amount of messages. Because the truth is that you would want messages to be shared across applications. And how would these messages be shared across applications? They can be shared across applications in what we call Azure Queue. Is what we call Azure Queue. Please be rest assured that some of these things we are discussing will still be discussed in our class, right? That we are going to start tomorrow. Is that noted, guys?
Yes, it is.
Yes, it is.
Now, the last thing here is called Azure Tables. Oh, no, sorry, the next one is called Azure Files. Azure File is just like a normal folder in your system. For the experienced server administrators on the call, on this meeting, on this training call, you agree with me that we've always had file infrastructure, right? The file infrastructure is what is behind our file servers, isn't it? Where we map storage volumes to the systems of users' computers using what we call group policy, isn't it, guys? Or we create a shared folder that will be mapped to users' computers where they can actually keep a centralized document. So the replica of file infrastructure that we have on-prem, that replica of file infrastructure in the cloud is called Azure Files. Because SMB protocol is a protocol used by file infrastructure, which is within our on-premises infrastructure. So for those of us new to what I'm saying, do not worry. Did you get what I'm talking about? Just take note of what I've said. Is it clear? When you're involved in a project in future, you get to understand the importance of these 5 things I'm talking about. The last concept, but not the least, is called Azure Tables. The Azure Tables is also the kind of tables, just like a database tables, utilized by applications to store data. So there are some applications you want to develop, because this Azure table is actually a Cosmos DB tables. It's like a Cosmos DB tables, right? Right? These tables can be utilized by application to store data. When you are developing an application and you are trying to reference any of these storage points in your code, right? Here is the URL that will help your application to talk to blob storage. Can you see it? Because when you are developing an application, you might want to reference a public endpoint of an Azure storage service. If you are referencing Azure blob storage, here is it. If you are referencing data lake, here is it. Azure Files, here is it, and the likes. Like So as far as Azure Storage Access Tiers is concerned, there is what we call, there are different categories, right? There are different categories of access tiers. There is a hot, there is a cool, cold, and archive. Let me just summarize. These access tiers help you to optimize, right, your storage space. If you have chosen your storage space to be hot tier, right, what it simply means is that that particular storage space is optimized for storing data that is accessed frequently. So you don't want a scenario whereby within the hot tier, data that are accessed once in 3 months, once in 6 months to be kept there. So in hot tier is dedicated to a storage that would store frequently accessed data, followed by cool tier. Cool tier means it's a storage tier meant for data accessed infrequently, maybe once in 30 days. Cold tier means once in 90 days. Archive tier means once in what? 180 days. But the interesting thing is that if your tier is set to hot, you can configure what we call lifecycle management rule that will automatically move the content within the hot tier if it exceeds the expected duration within the hot tier. So you might say anything that is accessed more than 7 days should be moved to archive or moved to archive. You can configure a rule to achieve that. Is that noted, guys?
Yes.
Yes, it is. Just like a bank, you can say
yes.
Asking for account balance, move it to
exactly. Yes, exactly. Now, when it comes to migrating your VMs, migrating data, you can adopt what we call Azure Migrate. So Azure Migrate allows you to perform, it's a unified migration platform, right? That allows you to migrate resources from on-premises infrastructure to what? Azure. Is that noted? And there is what we call Azure Data Box, right? Azure Data Box.
Sorry, I just
Azure Data Box. Yes, please go ahead.
Yeah, okay. So I just wanted to ask a question related to the last slide we just concluded. I just want related with GT Bank transaction for maybe you want to get your transaction history. I noticed recently before GT Bank, once you perform transaction, once you close the page, you can still revisit and get that transaction slip again. But recently, once you close the page, when you go back, you don't have any transaction history. So what are they using? Hot optimized storage, or what type of storage are they using? Because it seems they don't seem to have history anymore. Hello? Can anybody hear me?
Yeah, I can hear you.
Yes, I can hear you. GT Bank has history now. So maybe it's I'm using GT Bank. You can check your history transactions.
You say?
I say you can check your history transaction now on GT app.
New.
I'm using GT.
New.
Yes, I got it correctly.
Yeah.
Hi. Yes. Was it Farouk that asked that question?
No, I was the one. I was the one. Samaila was the one that asked the question.
Oh, okay.
Yeah, let me rephrase the question again. So, the previous version of the GT app, once if you perform transaction, you can revisit and get the transaction history and reprint the slip. But recently, I've noticed that for countless time. Once if I perform transaction, if I really need that particular receipt, except if I send it somewhere else. Else, if I move out of that particular page at the moment, I don't know whether I'm the only one experiencing this, but someone was saying that he can check, but I don't even know whether you are still using the old version. But if it's the same version with mine, then I don't know. So I was asking, is it that GT, are they using the old type of Azure storage for that kind of activities?
Okay, so you were asking if it was archive or auth, right?
Yes.
Or pull or code.
Yeah.
Yes, that is also possible. Is it clear? You understand?
Yes.
Because they don't want a situation whereby the storage, right, will get filled up as a result of infrequently accessed data. Is that noted?
Yes. Yes. Yes, I understand.
Yes, it's possible.
Okay, so they did that purposely because they just want to like a kind of protect the system from frequent access of historical data. But
absolutely.
Okay, but don't you think it will, when you look at it in order, like OPE you can revisit and reprint even after 1 year. So I don't really understand. So when we look at it, I don't really understand what model are they trying, or is it maybe because of the kind of database they're using? Okay.
It's an operational strategy actually.
Okay. Okay.
You get what I'm talking about. And it might not necessarily be this tier thing we are discussing.
Okay.
Is it clear?
Yeah.
It might just be something you experienced at that point in time. You got what I'm saying, Smiler?
Yes.
So I would like us to put it in the right context. It might just be an issue peculiar with the version of the app you are using.
Okay.
Do you get what I'm saying?
Yes.
But what we are basically talking about is that the storage tier, right, for frequently accessed data is not expected to keep infrequently accessed data or rarely accessed data. Did you get what I'm saying?
Yes.
That is it.
All right. Thank you.
There is what we call Azure Data Box. The Azure Data Box is actually a form of, is a migration strategy, right? Because it basically helps you to, it's basically just like a backup recovery tool, right? Because data box is just like a normal hard drive. Is that clear? It's a normal storage equipment. Huh?
Yeah.
Are you getting what I'm saying, guys?
Yes.
Yeah.
This,
Yes, yeah.
So this is just like a normal disk storage equipment. And the essence of this storage equipment is basically to keep a copy of your data. Did you get what I'm saying? A copy of your data. Right? So they are just backup option.
Yes. Hello, Mr. Shegun. It's 1 p.m. It's time for the long break.
Okay. Let's go for it. We'll convene by 2. Thanks, guys. See you guys.
Guys, please, let's be conscious of the time, okay? And let's be back here by 2 p.m. so we can round up for the day. Thank you all.
Thank you.
Thanks.
Thank you.